Okay, so in this video, we are going to review the concepts about radiation. So, sa radiation, ito yung pangatlong mode of heat transfer wherein electromagnetic waves are passed from one body to another through space. Okay, and we have the following formulas para ma-solve natin yung heat transfer due to radiation. First, we have emissivity times sigma, wherein sigma is the Stefan Boltzmann constant, times the surface area, times the temperature raised to 4. So, ito ay kapag isang body or isang enclosure lang yung pinag-uusapan natin. While itong pangalawa, gagamitin naman kapag ang pinag-uusapan is net radiant exchange between two surfaces. So, kung halimbawa may dalawang surfaces, then given yung temperature ng isang surface and yung temperature ng isang surface, nagkakaroon ng exchange ng radiation energy, ng radiant energy between those two surfaces. And to solve for that energy, ito yung ating formula. Emissivity times sigma times area times T1 raised to 4 minus T2 raised to 4. And lastly, we have H sub R times A times T1 minus T2. Ito kamukha nung formula natin for convection, which is yung HAT. So, dito naman, sa halip na convective heat transfer coefficient, ang gagamitin natin is yung heat transfer coefficient due to radiation, kaya H sub R. Same lang sila ng formula, pero magkaiba yung values ng for convection tsaka yung for radiation. Then, ano po yung emissivity? So, emissivity is the ratio of the emission from the gray surface to the emission from a perfect radiator at the same temperature. Kapag black body, merong value ang emissivity equivalent to 1. Kapag ka naman white body, equivalent sa 0, at kapag gray body, equivalent sa 0.7. Pero kung halimbawa nawala dun sa tatlo, ibibigay naman yung value ng emissivity. Okay? Then yung sigma, yung Stefan Boltzmann constant is equivalent to 5.67 times 10 raised to negative 8 watts per square meter per Kelvin raised to 4. And kapag English unit ang pinag-uusapan, 0.1714 times 10 raised to negative 8 BTU per R per square feet per Rankine raised to 4. And in case na makalimutan nyo yung value ng constant na yan, pwede natin kuhanin dito sa calcu. So, shift constant, number 31, lalabas yung symbol na sigma, Greek letter, ayan. Then, press equals 5.67 times 10 raised to negative 8. So, ito ay SI unit. Huwag nyo lang kakalimutan yung unit. Then, yung temperature dito, since kung napansin nyo, yung ating unit ng constant, ng Stefan Boltzmann constant is naka per Kelvin raised to 4 and per Rankine raised to 4. So, required na yung gagamitin yung temperature dito is naka-absolute. So, kailangan kung naka-degree Celsius, i-convert nyo muna siya to Kelvin, or kung naka-degrees Fahrenheit, i-convert nyo muna siya into Rankine. Okay? So, huwag nyo kakalimutan na absolute yung temperature. And dito, yung naka-raise sa 4 ay yung individual. T1 naka-raise sa 4, T2 naka-raise sa 4. Iba yung sagot kapag yung difference nila yung ni-raise sa 4. T1 minus T2, then yung quantity raised to 4, mali yun. So, dapat ay T1 raised to 4 minus T2 raised to 4, wherein yung temperature, again, ay naka-absolute. Okay, so let us try to solve problem number 1. So, sabi dito sa sample problem number 1, a large black body enclosure has a small opening area of 1 square cm. So, merong area equivalent to 1 square cm. And then, the radiative energy emitted by the opening is 5.67 watts. So, merong heat transfer due to radiation equivalent to 5.67 watts. Determine the temperature of the black body enclosure. So, ang hinahanap is yung temperature ng black body. So, sinabi doon na black body. And kapag black body, ang ating emissivity ay equivalent sa 1. At again, ang sigma is constant, 5.67 times 10 raised to negative 8. So, again, ang ating formula na gamitin ay equivalent sa Q is equal to emissivity times sigma times area times the temperature raised to 4. At dahil temperature ang hinahanap, so si T raised to 4 ay equal sa Q over emissivity times sigma times area. And para makuha natin yung temperature, kuhanin natin ang 4th root ng both sides or erase natin sa 1/4. Erase natin sa 1/4. So, cancel to. Therefore, temperature is Q over emissivity times sigma times area raised to 1/4. 1/4. So, yan na yung ating formula. Now, let us substitute the given into this equation. So, si T ay equal sa Q, 5.67 watts over this emissivity which is 1, hindi ko na isusulat, times sigma. So, yung sigma is 5.67 times 10 raised to negative 8 watts per square meter per Kelvin raised to 4 times the area which is 1 square cm. So, ang ating unit ng area dito ay square cm at square meter. Kailangan natin i-convert para ma-cancel. So, para ma-convert natin yon, ito, i-divide natin by 100 cm. Kasi, ang 1 meter ay merong 100 cm. Pero dahil naka-square yan, kaya itong buong ito, i-square din natin. Okay? Then, yung buong equation ay naka-raise sa 1/4. Okay. Now, let us solve. Solve ko lang. So, 5.67 divided by 5.67 times 10 raised to negative 8 times 1 over 100 dahil ngayon ay area, naka-square. Press equals. So, 1 times 10 raised to 12. Then, i-raise natin sa 1/4 or 0.25 para makuha natin final answer. And, the temperature is equivalent to 1,000. So, T is equal to 1,000. Now, anong unit nito? Cancel yung watts, cancel yung square meters, dito yun ang galing sa area. Then, yung Kelvin raised to 4, naka-raise sa 1/4, so ang unit niya is Kelvin. Thus, yung temperature nung black body is equivalent sa 1,000 Kelvin. So, that's all for problem number 1. Let us proceed with problem number 2. A black body filament is heated to 2,300 Kelvin. What is the maximum radiative heat flux from the filament? So, given yung temperature, for problem number 2, temperature is given 2,300 Kelvin. Ang hinahanap is the radiative heat flux. Pag sinabi natin heat flux, yung small letter Q yung ginagamit natin. Yun ay yung malaking Q naka per unit area. Okay? So, solving for Q, dahil wala ngang area, Q is emissivity times sigma times temperature raised to 4. And yung given is black body. Thus, yung ating emissivity ay 1. And sigma is nasa calculator nyo, pero sulat natin 5.67 times 10 raised to negative 8 watts per square meter per Kelvin raised to 4. And yung temperature is given 2,300 Kelvin. Naka-absolute na. Wala na tayong kailangan i-convert. I-raise na lang natin yan sa 4. Then, computing for heat flux, lumalabas ng sagot is 1,586,698.47 ito. Or 1.587 times 10 raised to 6. Ano unit niyan? Cancel natin ang Kelvin raised to 4 watts per square meter. So, ito na yung ating final answer. Kung gusto niyo yung exact yung sagot, okay lang. Walang problema. Okay? Then, problem number 3, we have, after sunset, a person is standing near a brick wall can sense a radiant energy. Such walls frequently have surface temperature around 44 degrees Celsius and typical brick emissivity values are on the order of 0.92. What would be the radiant thermal flux per square foot from the brick wall at this temperature? Okay, so yung given for problem number 3 is temperature na 44 degrees Celsius. Ang emissivity is given 0.92. Then, ang tinatanong is the thermal flux or yung Q per square foot. So, naka per square foot. And kung ang gagamitin natin na constant ay ito, watts per square meter per Kelvin raised to 4, ang makukuha natin per square meter. So, para ang makuha natin ay per square foot na diretso, ang ating gamitin na sigma is yung kanina, 0.1714 times 10 raised to negative 8 BTU per hour per square foot per Rankine raised to 4. Now, yung ating temperature ay naka-degree Celsius. So, ang gawin natin, i-convert natin to papuntang Fahrenheit. And para mas madali, gamitin natin si calculator para mag-convert from degree Celsius to degrees Fahrenheit. So, shift 8, convert 38. Okay, so degree Celsius ay 44, papuntang Fahrenheit equivalent sa 111.2. Pero dahil ang kailangan natin ay naka-Rankine, paano ba tayo magko-convert from Fahrenheit to Rankine? So, ang gagawin natin, from Fahrenheit, gagawing Rankine plus 460. So, adding 111.2 and 460, ang sagot is 571.2 Rankine. So, 571.2 Rankine. Then, substitute natin yan sa formula ng Q to solve for the heat flux, emissivity, sigma, times temperature raised to 4. Substitute, so may emissivity na 0.92. Then, yung sigma na lang ilalagay ko. At ito naman, nakasulat na, hindi na kasi kasya dito. Times temperature raised to 4, 571.2 Rankine raised to 4. So, makakansel lang na unit ay yung Rankine raised to 4, tsaka yung Rankine raised to 4. Ang matitirang unit bale is yung Q over A. Ang Q is BTU per hour, area per square foot. So, BTU per hour per square foot. Thus, ang heat flux per square foot is 0.92 times 0.1714 times 10 raised to negative 8 times 571.2 raised to 4. Okay, so 167.8616. 167.8616. Ang ating unit is BTU per hour per square foot. So, ito na yung ating final answer. Okay? So, yan na yung ating problems number 2 and 3.